Greetings, math friends. I'm going to talk about the freshman's dream today, and I'm going to talk about it in two different algebras. And we are going to look at what it means to define an exponent, because that's important, and how that's going to operate. We typically define an exponent, some base a to the n power is going to be indexed from 0 to n minus 1, and we want the product of a sub I. So that's going to be a sub 0 times a sub 1 times however many terms that we have to get to n minus 1. All right, so we want the product of this. So I think many of us know when we're looking at something like a squared, so we definitely fix this n value as a 2. We are looking at a times a. This is our sub 0. This is sub 1. N minus, so our n value is 2, so 2 minus 1 is 1, so we have 0, 1 here. So we're looking at a times a. When we look at something of the nature of a binomial and we square this, what does that mean? Well, that's going to be driven from this definition. So this is going to be our first algebra that we discuss. All right, so looking at classical algebra, this is the algebra that you learn in high school. We're going to look at this binomial squared. According to what we have established here, that's whatever the base is times itself. So this is a plus b times a plus b. So when we do this, this is a matter of a double distribution. We're going to distribute the b over this first, and then we're going to distribute the a over this next. So b times a is ba, b times b is b squared, a times a is a squared. These need to be added in here. And then a times b is a b. So then we look at simplifying whatever we can and adding. This is addition. So we have b squared, I don't have any like terms. A squared, I don't have any like terms. This b times a and a times b, because a commutative property, is the same product. So we have two of those. So we end up with a squared plus 2ab plus b squared. So when we look at classical algebra, we can't look at this as the exponent distributing inside the parentheses, because the product of this is this polynomial. A lot of students forget this middle term when they're out of practice in doing this. So the freshman's dream would be if this exponent simply distributed inside of there, and that's going to be our second algebra. So for clarification, I want to establish that in classical algebra, our a and b terms are elements of the real number field. This is what we're used to in middle school, high school mathematics. All right, we're going to look at tropical algebra now. And a and b are elements of the tropical semifield. And so we have a slight modification here. This plus with a circle around it, this is indicating that we are doing addition in this tropical semifield. So it's addition as defined in the tropical semifield, and then the multiplication that we do will be the multiplication that is defined in the tropical semifield. And so this is going to be AB times AB. And now we have to do our distributive property again. All right, I'm going to multiply A times A to get A squared. And then I'm going to multiply A times B to get AB. And then B times A to get BA. And then B times B to get B squared. Now the interesting thing about tropical algebra is when we add two terms that are the same together, we just get that term back. So this will simplify to this, and it starts to look like it did in classical algebra. If we look at A squared plus AB, in tropical algebra, you get the minimum value back when you add two terms, so you get the A squared back. So this is equivalent to A squared plus B squared, which is the expectation we were looking for. It looks like this 2 distributed inside the parentheses, so this and this are equivalent statements in this algebra. So this gives us the freshman's dream if we change the algebra that we are in. Classical algebra, it doesn't look like it distributes. In tropical algebra, it gives the appearance that it does distribute. So this and this are equivalent. Hopefully this has been interesting. Cheerful calculations.